right, off you go.
Thank you, thank you. It is such a big pleasure to see you. That's not just words to be polite. That's really this way. Because, you know, we met 8 months ago with Bojan and with Odd on PyCon Slovakia. Back then, they had these crazy eyes. Odd came to me and said, hey, we're going to make this conference in Belgrade. And we want it to be international, so it will be not just Serbia. And it will be in Hilton. And it will be 500 people around that. I thought, wow, I mean, you're either underestimating it or you're just crazy and wild. So it asks, like, can you give a talk? I said, yes, of course, I like crazy. Now, imagine what I feel. Imagine what I feel now. They did it. It worked and it's perfect. Can we make a bravo for the organizers, please? No, it's really cool. It's really cool. I think everyone is happy and impressed. Well, anyway, another thing that Odd asked me was my position to put me on the website. And well, what I do, I run the agency, I do everything. I deliver software to the customers. So I thought, let's put a delivery boy. So if you're wondering why, that is why the legend. And I happen to know these things about the conferences because we also organize conferences in Munich. It's PyCon Web and PyCon Germany a few years ago. So I know how tricky it is and I know what effort it is to pull out an event like this. And it is really cool. Anyway, the talk is not about that. The talk is about the data, the algorithms, and the people. I have first a question. Do you think that it is realistic nowadays for one person to have an impact in the world? Is it even possible? Who is optimistic? Who is pessimistic? All right, I think a bit of both. Well, you can believe it or not, but the world we live in, it's full of the algorithms and of the data, and this is something that currently rules our society. We are just very little on the scale of this big digital revolution that is happening right now. And if you want to escape the digital revolution, well, I guess you need to go somewhere deep in the jungle before they destroyed it, because it's now happening everywhere. You like it or not, but algorithms are indeed everywhere, and this system is doing stuff all the time. It's pessimistic, but we people, we are just rows in many systems out there. And the systems, algorithms, are sorting these rows. And then they are dividing us into the winners and the losers. And the winners, they get best conditions, and the losers have to pay more or are not invited at all. I know it sounds pessimistic, but think of this. For instance, in most of the countries on the West now, there is something like a credit score. It's in Germany, in the US, everywhere. The credit score is something that shows how likely will you pay your bills, something like that. I have an example. A friend of mine, he's also a developer and a very good businessman. He sold his startup and moved to Berlin to start the next one. I visited him a couple of months later. He was still living in the Airbnb apartment. I asked, what the hell, man? Are you like, nothing fits your royal standards now or what? He said, no, it's an opposite. Nobody gives me a flat. He does not have a permanent contract. And so the system ranked him as a loser. His score is really low and he cannot get a flat. That's as ridiculous as it is. Another example, if you get a new car, like a powerful sport car, even if you never had an accident, the system will force you to pay more for the insurance just because you are more likely to have an accident, even if you never had it. Well, if you had it, then you're even in the bigger trouble. Another friend of mine, he hit a bicycle. It was nothing bad, but nonetheless, he had to pay a lot, and a lot in cash. I asked, isn't that exactly the case when the insurance should cover you? And then he said, theoretically, but if I tell the insurance, they will raise my monthly payment so much that it will be even more. I said, wow, that's a win-win business for the insurance, isn't it? And it's a good example when a person is afraid of a system, of the algorithm that is doing something with your data. So we totally are losing the control of our data, and that's not cool. We can go into more examples, like I know, the banks. When you apply to open an account in the bank, they ask you to fill in the application form. There is one field, nationality. And answering wrong to this one field makes you not a trustworthy person. They'll just reject you because of that. Now, this is not just a bad algorithm. This is a discrimination. So how come we live in such a modern, cool society? We have all of these privacy laws, anti-discrimination laws. We have our cool techie get-togethers, yet we still have to deal with this mess on a daily basis. And whose fault it is? And, well, You can blame the government, you can blame the society, but what I know is that behind every system, and we are talking about IT systems here, there is a group of developers who developed this system. And so it's actually us who should take the responsibility and to fix these things. So today, let's abstract away from these things. Let's have a fresh start, and let's think of like the nice way, how would we deal with these data tasks? Like easy, nice, and maybe, just maybe, even one person can then have some impact in this world. Let's start with the data. You know, there is this funny quote about the data, about the 5 exabytes. You probably heard it, like conference speakers like it a lot. It says that during these few days of a conference, we will generate more data than the entire humanity did before 2003. It's a bit weird in my opinion, so I decided to check it. I looked it up, and it's a quote from Eric Schmidt, which is indeed based on the IDC report. And it says that, yes, we do produce 5 exabytes. I think it was like 3 or 4 years ago. And we did produce 5 exabytes until 2003. However, not since the beginning of like the history, since the beginning of their research. And guess when their research started? 2002. 1 year only. So here we already have one little learning. Don't trust the data blindly. Check the data, check the facts. Because if you just blindly trust the data and do any sort of research on top of it, it doesn't matter how cool your algorithms are, how cool your tools are, it will be just wrong. Then, of course, this code still has some truth in it. Of course it does. Because we indeed produce a lot of data these days. But it also depends on what do we consider as a data. If we think of the ancient 5 exabytes, it's probably something like this. Like the writing process is extremely difficult. The storage is expensive, so we only write down the essential facts, like the key facts from the history, the big discoveries, only important stuff. And how would our 5 exabytes of today look? That's my guess. Would probably be something like that. Please don't get me wrong. Cats, they totally deserve all of the space, probably even 10 exabytes, that's fine. It's the base of today's internet. I admit it. Well, nonetheless, it gives us an interest in tasks as for data scientists. Now we have to take all of this 5 exabytes of trash and maybe try to squeeze a few useful bytes out of it. Because if it used to be that one smart person could probably learn most of the knowledge in the world, like a few hundred years ago, now even the best machine cannot even read all of the data that we produce. So we need data scientists to actually get some useful insights out of that huge trash pile. And that's our first task. For that, of course, we need tools. And who of you people are data scientists here? Good, so we can do some guessing. What tool do you think is the most popular one? There is a nice survey by O'Reilly that they run every year. I have the stats from 2017, so pretty much fresh. So which tool would be the most used? Maybe MATLAB. Who's for MATLAB? No, maybe Python? No. Yes, some optimists. Well, the most used tools is Excel. Microsoft Excel. That is not an advanced tool. So by this I just want to say that to do the data analysis, you do not need to be a PhD or whatever. Everyone knows Excel, and that's enough to do the basic things. And then I'm really happy that Python is already on the place 4. It's something. The place 4 is already something. It's pretty nice. And I want to say that the complexity of a tool shouldn't stop you from researching the data. You can do most of the data analysis even with simple tools. As you see, Excel and SQL, that's easy, it's not a big deal. Now, the next thing that could probably stop you is math. Well, there is this common myth in the data science that you can do nothing without math, because math is like the basis, you need math for the algorithms and so on. So when people say you need math, they probably mean something like this. In reality, it's more like this. So yeah, it's math, but it's a high school math. It's not like the crazy math. Everyone can really do it. If the data set is not too big, and it probably isn't, all that you need to find some basic patterns is probably just to sum things up and find means and plot them. It's like 80% of the cases in most of the industrial projects these days. And you might probably think, your agency is just lame, you do this lame math, there is some real math somewhere. Well, you can be right, but then again I'll show you the survey from O'Reilly, which says that the #1 task of a data scientist, and not just some data scientists, these are those who attended the data science conference, is basic explanatory data analysis. Basic data analysis. This is what the market needs. So you don't have to be a crazy mathematician to have an impact in the industry. Neither you need crazy tools. Because the tool at the end, the tool is just a tool. And there are many funny stories about tools, also from people who didn't like tools and created their own. Some I want to present to you today. Maybe it inspires you a bit. Probably you know Stefan Wolfram. That's the author of Wolfram Mathematica. It's funny if you know how it started. He's a physicist. He just wanted to do his physics tasks. But one thing he noticed is that when we people brainstorm, we often use notepads to write things down because thinking process is iterative. You write things down, you do your calculations, you do it again, you change some parameters, you run it again. And back then the software wouldn't do it. You have to write a set of instructions, run it, and start from scratch. So it wasn't really working that well for him. So he just wrote a little tiny tool that was more of this notepad interactive environment for him. And he released it, and he founded the company, and oh, surprise, he got the market's lead right away. Now it's, I think, something like 600 or 700 employees that he has, and he was a leader for a really long time there. Just a physicist who wanted to do his research. He wrote a tool for himself. He didn't want to change the world, but in fact, he did. This is how Wolfram Mathematica looks right now. And you probably see it. We have something similar in Python, right? We have IPython or Jupyter notebooks. And here I'll tell you another story from Fernando Perez. He's also a physicist. They probably have this something crazy DNA or whatever to invent things. Anyway, he used Mathematica. He loved it a lot. But it's a commercial project, and people are not that eager to write extensions for Mathematica themselves. There are not many. So if you need the integration of Mathematica with some, I don't know, complicated medical system, you won't have it, and you won't write it either, because it's not open source. You have to either ask somebody from Mr. Wolfram's team, which is probably zero chance they will implement it, or you have to wait, or you have to write something yourself. And that's what Fernando did. And he started the IPython project back then, basically copying Mathematica with open source concept in mind, that it will not be him or his company who will be contributing stuff, but that it will be everyone. Everyone in the world who needs some data science tasks or data analysis tasks and needs this notepad environment to do the research would use it. And it worked. Then, since we already touched the visualization anyway, I'm going to switch to this point because there are many tools, there are many stories. Every tool deserves an own talk by itself. However, often overlooked part is the data visualization in the process of data analysis and data wrangling. So it's because of the way the human brain perceives information. It's like that we can recognize visual patterns much faster than we can process a table of the data. Visual information is more human-friendly, and we are humans, so it's easier for us. And we can just make a little experiment here. Everyone remembers the everlasting smartphone patent wars. Apple, Google, these stories. I'll just quickly show you something. Hold on. Here. Okay, so this is the Wikipedia article about the patent wars. And here we see the Wikipedia at its best. There's pure facts, nicely grouped by years, and you see the very, very core details, what happened, who sued whom. Now, let's look for a few more seconds on this and try to answer my question. In the year 2010, what was the company that sued Apple, but Apple did not sue them back? It's hard. It's not really comfortable. So why don't we just visualize it? Maybe it will work better. I'll have to do some jumping from one window to another. You can see this, right? Yes, you can. So this is the first example that I will run really fast in the Jupyter notebook. Somebody just nicely put these suit cases in the JSON format so that we see the facts who sued whom when. This is just a snippet for 2010. We nicely visualize it now. And here we go. So if we take a look on this, it's pretty easy to notice that Apple sued back everyone except of Kodak. And imagine how much time are you saving by visualizing stuff like this as comparing if you would have to read the text. That's insane. And please don't think that Apple gave up about Kodak. They just sue them next year. So it's all fine. Going back here. Yeah. So indeed, we parse the visual information better in some cases. But can we take even bigger data sets and squeeze something more more condensed out of it? This is just an example that is used a lot on the internet, also in Python. It's a book, Les Miserables, where somebody just extracted the key interactions of the characters inside of this novel in I think in the JSON format. It's basically a matrix. Yeah, it's a CSV. It's basically a matrix, who spoke with whom, how many times, stuff like that. So without reading a book, we will try to understand some social circles that are inside of this book. Here it is. Here you see. So on the left side, you don't really see names because of the size, but it's okay. So on the left and right axis, you see just the names. It's basically a matrix, who spoke with whom, how many times, nicely sorted. So without reading a book, you can see the social connections, like this group has or this group has, and you can also see some strange interaction outside of these groups. That would be, for instance, a good case when you do some private detective stuff. You want to analyze stuff from Facebook. You can do the very same thing. And you can already see which of the characters broke out of the social circles. That could be suspicious, right? But my favorite part in here is this little block on the top left corner. It's child 1 and child 2. I feel sorry for them. They just talk to each other. And that's without reading a book. That's just an example how we took a big book and squeezed really, really key insights out of it. Oh, true, here, yes. Well, it's probably this person talking to them, I suspect. Probably parents or whatever. Good. On this example, we took a story and we made a boring matrix out of it. It's not cool. Can we do the opposite? Can we take the boring data and make a story out of it? Anyone knows The Wealth of Nations? It's a very, very popular TED talk by Hans Rosling. He is like a visualization master. He took the basic data from the economy and the healthcare and the history, plotted it into a story of every country in the world. You'll see it in a sec. Of course, we are interested. He used crazy tools to do that, but we have Python. So we're interested, can we repeat the same thing just using Python and Jupyter? As you can already guess, yes, we can. So I'm loading the same data set that he used, nations.json, and I'll explain you in a sec what exactly is this thing doing. So this is a plot. On the left, you see life expectancy, like how old people, how much people can live. And on the right, you see their income, how rich they are. And this data goes from 1908 to 1910, I think. And you can, every circle is the country. And depending on the size of the country, accordingly the size of the circle, you see things happened to Germany, for example. Let's play it. It, of course, doesn't make sense without tracking a particular country, but still, you see how it moves, and I'll show you some details now. Like, okay, now we are in 2008, and I found Serbia. It's here, Serbia. It's a pretty good development. You see that the country just was extending the life lengths very stable and regular. It was not getting so rich, and in times of, I guess, Yugoslavia, got a bit back, but nonetheless the life expectancy was still growing even during times of the Yugoslavia war. This is good. There is more interesting example, for instance, if you take Saudi Arabia. They got rich fast because they discovered oil, but they didn't live long. So what they do? They took some oil money and put it into healthcare. Then they became not so rich. As you see, it went on the left, but the life started to be longer. This is economy versus healthcare in practice. And you can plot this for every country, and you can see the history of every country here just using this little code snippet here. basically learning the history plus economy of this particular country within just one graph. And this saves you a lot of time considering the amount of data you would have to read if you want to achieve if you want to get the same knowledge, and you only have a book to do this. Now back to the presentation. You might say that this is still just games. Do we have something serious? Can we do something serious with this data analysis and the tools that I'm promoting in Python? If you can read this word, already good, very good. I had to train. It's magnetoencephalography. They call it brain scanning. I know some researchers that do that. It's a very, very important topic because basically what they say is that the brain diseases are the one least researched. We approximately know how our body works, except of the brain. And when we are speaking about the psychological diseases like schizophrenia or even something simple like depression, we have no clue what happens here. It's just that the psychiatrist is just guessing. You are making your voice louder, probably schizophrenia. But there is no proof, and we have no idea what's happening there inside. So what these scientists do is they put some sensors next to your head, and they measure the currents that run, the impulses that run in your brain. And you can imagine how much data they get out of it. It's insane. It's terabytes. You cannot process it in Excel. You have no chance even of just opening the file on a normal computer. But Python helps. I have to say right away, I have no clue what this thing is doing. I copied it. I just made it a bit nicer. But this is the serious research already that I just wanted to repeat on my PC. So I had to cut the data set a lot just to show you how it looks. This is just the map of the sensors that measure our impulses inside of our heads. Then we also want to have a timeline, a signal. These are the signals from different points in our heads. What they try to do is try to analyze. They're showing you images and how your brain reacts to it. They also try to put you in uncomfortable situations so that your brain reacts differently. And then they try to see the pattern there. And obviously you cannot find any pattern if you don't visualize it. When you move, I'll make it bigger. When you move the timeline here, you basically reproduce what's happening down there. You see the dots are being active at this moment. You see what region of the brain. If you are a scientist, you know what regions are there and what that could mean. Of course, me, I'm just looking, hey, the dots are flashing, cool. But if you're a scientist, you actually understand this. But then it went more complicated because they say it's not enough. Like this flat view is good, but we need maybe to zoom in particular region of our head. Maybe we just want to research one little particular region and its activity. So then some totally random people from another country suddenly are contributing a JavaScript library. I think it's from the US and the research was in France. Contributing some JavaScript library that can do the very same thing, but now it can do it in 3D. And it can take any shape and any amount of the sensors, well, in reasonable range, of course, to do the plotting. And they support any shape of, so you do not need to measure currents only on your head. You can theoretically also measure your body impulses, like from your muscle. And it opens the doors for the next researcher out there in that university. And if that researcher is contributing something, he leaves something for the next generation. And that's how it works in open source. That's how it works in Python. And that's how it should work in data science. When we share things and we develop things and we actually can achieve something, even by being individuals, because these things is not made by big teams. It's like 2, 5, 10 maximum are the teams in these medical universities that are doing this. Now let me go back to the presentation. So, yeah. I hope that I proved to you that you can do real things with Python, with its basic data science stack. I didn't go in details on purpose. I want to showcase, to tease what is there, what is available, and what can you achieve with it. But I omitted one last but very important thing that helps us here. So with help of these technologies, we can achieve a lot. And obviously, we wouldn't be able to do this big data revolution without using our powerful computers and our powerful algorithms and tools. However, there is one element, and it is in fact the most important element that drives insights out of the data. It is something that the data scientists have, and their tools and machines don't. It's a human factor. It's a human factor, and you might not think of it at the beginning, but it's in particular some qualities that we humans share and machines don't have it. For instance, we all have access to Google, and also machines have access to Google. But it is our curiosity that dictates what are we searching for, how are we filtering it, and how are we reacting to it. Then comes the empathy. Empathy is the way that we try to understand others, something that tool by itself won't do as well. We try to understand where is this field where we can do something, and we try to do there to help others, to make the impact. And then when we do our tasks, the task usually looks, at least in the data science, like a big puzzle with a lot of missing pieces. So machine learning is not there yet to fill these gaps. For this, you need a human with a quality of imagination. Without imagination, you won't fill the missing gaps of this picture. You need real human factor to do this. And then finally, not all solutions are trivial. Not all solutions can be described algorithmically. You need creativity to target these solutions, to find them. Then when you have it, you need communication to spread these ideas, to contribute them, to understand the sense even of contributing the packages on PyPI or just sharing it with your coworkers. And then finally, last thing is the leadership. The leadership is this quality when you step up, you gather like-minded people like yourself, you do something just like the organizers did at this conference, and we can say we can change the world and we can have at least a little step in it. Thank you. I obviously didn't do even 50% of the notebooks, so credits, it's all available online. I think this presentation will be also published somewhere, so you can have it in a shorter way as well. So yeah, please, let's have some questions.
Okay, guys, raise your hands. Any questions? Come on, someone. Anton, what's wrong?
Well, it's either a good sign or bad sign.
I don't know.
It can mean that everything is clear or everything is
there's one.
very unclear.
Hello, sir, you raised your hand.
Okay, so what's like the best starting point for somebody who actually wants to get into data science? It's a very broad question, I know, but...
Yeah, it depends. If you just want to learn, of course, I would recommend to take one of the examples that are already implemented. Just go through it. It's not bringing much value because you are repeating the work which is already done, but it helps you get on board really fast. And there are dozens of the tutorials, dozens of libraries. Of course, I would recommend you Jupyter Notebook because it's a de facto tool now, but you can pick any. I would say you take one of the examples that is already available there, you go through it, and when you feel like, okay, now I can do something by myself, you need to find the case that interests you. In Europe, it's a bit problematic. I don't know about Serbia, but in Germany, data is not so open as it is in the US. You can take, I don't know, the statistics of accidents on every street in every time of the year and match it with the weather or with the holidays in US. In Germany, we don't have it, so you have to be creative to get the data. But maybe you have better luck here or in the neighboring countries, because in general, what happens with your neighbors probably also concerns you. And I would say you find some interesting case and you'd be surprised what insights can you get out of this data. It's insane. There are correlations that are not advertised because it's not so cool news as naked Paris Hilton or something like that. But they are really interesting, and for me personally, and I'm sure for all of the scientists here, it will be much more interesting to do some research like that and see some untrivial correlations concerning our lives.
Any more questions? No, there's
yes,
one.
Please.
It's going to be a run. I can do it. Here you go, sir.
Thank you. So did you work with Modis and Ray to speed up the pandas, and what do you think about Keras?
Well, Keras is another topic. I didn't use Keras here. I used it in my projects, but that's a whole different topic, the whole machine learning stuff. Obviously, if you are speaking about playing with notepads, basically as I did right now for this presentation, it's a funny data set. It's just a few kilobytes of data. You do not need arrays. You do not need even NumPy. You can do everything with standard Python tools. But if you want to do the serious data science, at some point, of course, you need to understand the non-so-trivial data structures that only NumPy can give us at this point, I believe. It depends on the case. However, I wouldn't say that you have to start with it, because it's a rare case when you are blocked right away by the performance of your software, usually blocked by something else. And then there is this long period when you try to understand the data and you try to formulate your question right. And for that, it's usually enough just to cut your data set on a smaller size so that you can operate on it faster. You can find some basic visualization faster, you can write your scripts faster, and then when you're sure that you're on the right path, like you formulated the task correctly, obviously, yes, you do need NumPy and you need all of the data structures there if your data set requires it. But then, well, it's a similar code, it's compatible. I wouldn't say that you have to write the whole thing again. You usually need, as you mentioned, you usually need arrays. You just replace the arrays, you replace array operations, the thing will work. So you don't have to start with it, but eventually I suspect that you will need it. And yes, I need it. Thanks.
Okay, one more question. Was there a hand or just a slide?
You said that you need to be creative in Germany to get your data. Can you say some way how you get your data, or are you not allowed to say it?
No, of course you can. Well, usually the problem is that it's legal, it's available, but it's not published. So it's a problem not of the legal side that you are not allowed to access it. It's a problem that it's just not visible anywhere. You need to write an email to whatever authority, to police. I'm from this university or company or whatever. I want to do research of the accidents. How can I get the data? And they will most likely provide it to you or point you where it is. But there is no central registry. There is, but there is nothing in Germany. There is a registry, but the data is just of some cities that released it there, so because it's not obligatory to publish it. So you have to be proactive, you need to push the authorities, and sometimes you just don't need, like, who is responsible for, I don't know, for rain? What is the rain authority? You want to have days when it rained, whom should you contact? This is a problem. But if you are creative and you come up with this idea, whom can I annoy to get the data, you will be most likely available to get it, because there are also many laws about the openness of the public data that they actually have to provide it to you on request. So the request is a difficult part in this case.
Okay, if there's no more questions, we have a 20-minute break. Anton,
cool.
Thank you very much.
Thank you.
Hey, I'm Anton. Just finished giving my talk. I really enjoyed this conference. You know, as I said, I was speaking with organizers since like 8 months about it. I didn't believe it will happen. It did happen, and it's cooler than I could ever expect it. So I can totally recommend you. You should certainly come.